Statistically Significant Mini Project 2, Electrical Engineering by
Michael Reklitis
and Hepelin Quezada. Part 1, Key Characteristics. Electrical engineers design, develop, and test electrical equipment. They specialize in communication and signal processing, which focuses on efficient processing and transmission of data, and by transforming and analyzing signals, for example, providing an internet connection. Hardware and software computer engineering and control systems, which deal with automated processes such as an assembly line. Electromagnetics, which study the interaction between electrically charged particles, and they work with generators. Microelectronics, they design and use microchips and microcircuits. And power systems, which deal with the generation, transmission, distribution, and utilization of electrical power. Part 1, A Day in the Life of an Electrical Engineer. These engineers work in a variety of industries, such as aerospace, automotive, chemical, construction, defense, oil and gas, pharmaceuticals, and power and generation and utilities. They work in teams of other engineers to create and evaluate electrical products. They're also in charge of conducting performance, reliability, and compliance testing. They assist with troubleshooting and consult with other engineers how to meet the criteria and create cost-effective designs to finish in a timely manner. They also supervise manufacturing of electrical equipment such as electrical motors, radar and navigation systems, and communication systems and power generation. They also ensure that global standards are met.
For Part 2, Data Examples. First, we looked at the power distribution side of electrical engineering. We looked at things like demand, solar power, and wind power because they follow probabilistic tendencies. Things like clouds can mess with solar power, not very windy day will mess with wind power, and demand changes with day of the week or even time of day. Second, we looked at the maintenance side of power distribution. The equipment must be disabled to ensure safety of the technician. So engineers must look at peak hours to determine the best times to perform these maintenance routines. On the other side of electrical engineering, on the opposite side of the decimal point, we looked at communication and signal processing, and specifically bitrate errors. With any communication between electrical systems, ones and zeros being transmitted may or may not be received properly. The difference between what's sent and what's received is the bitrate error. This can be caused by various random properties within the system. As an engineer, we strive to minimize this. Part 3, Grand Challenge. For the Grand Challenge, we looked at virtual reality, VR. The big problem we were focusing on is how to get rid of cables. Current wireless systems we need to use to replace the cables can only carry so much data at a time. Using wireless systems, you have a high data error rate, like we brought up before, associated with them. For a virtual reality system, we looked at the HTC Vive, one of the most popular VR headsets on the market right now. It uses two 4K displays, one for each eye, to deliver the most realistic viewing experience. To power these 4K displays, a lot of information needs to be transferred across the cables. This data must move quickly for a high response time in the displays. This makes it difficult to use wireless communication. Here are our works cited for our content and our pictures. Thank you for listening.